There you are. Okay. Oh, well, we're all tired because it's morning. Well, not too early. We just woke up late. All right. Let's pull up the group meeting things. Oh. Well, I'm kind of scared about the next test.
Yeah.
I feel like we learned like so many things like so fast that yeah. I don't know. I don't feel like I quite caught up with them yet. Well, but it's still 2 days to it, so I have to take it. So.
Yeah, well, like 3. You have to go up there to take it. Testing center.
You can take it today, man, if you're feeling.
Oh yeah.
Feeling brave, dude. You know.
Oh yeah. Pass the test today.
As for me and my house, man, we'll follow the Lord. You know what I'm saying?
Yeah.
Okay. Week
4. Day 4.
Oh, I hate this. I learn every time I click on something, it takes forever to pull it up. Week 4. Where are you? There it is. Okay. And so it's the is it the week 4 day 5 activity?
Or day 4. I thought today's Thursday, so it should be day 4, right? Or am I all messed up?
Oh, day 5.
On Monday, day 5.
Oh.
Are we on day 5?
I thought Monday was day 1. It's Thursday. Shouldn't Thursday be day 2?
No, not yet. Day 4. May 17th. There it is. Activity A and an activity B. Oh. Okay. And logs and performance worksheet. Great. E to the U, guys, is just U, right?
According to her answer key, it's e to the u times u prime.
So. Yeah, why don't I pull up that answer key? It's been, I don't want to give you guys the wrong info here. See why I'm not ready for the test, man?
Same. I need the rules for this. Is that what this whole first section is, basically?
I'm basically going to memorize these while I'm working. I know that sounds bad.
I need to see them before I do them. Are these first four basically the rules right here? I don't remember.
Oh, come on. I have so many things pulled up. Where Oh, I see. That one's the one. Okay, now I got it. Okay, let me see here. When you have e to the u, the derivative of that is just e to the u times u. Okay. Which one was the one, though, that there was, that it was just e to the u? Is it the antiderivative? I remember there was one that was just something to the u, or something to the x.
Yeah, that's what I'm saying here on this other website. It looks like
Is just equal to the x.
Because I think we're doing antiderivatives here, right?
Are these? No, these are derivatives, bro. These are not antis.
Okay, yeah.
Yeah, if it's anti, it's going to have the integral.
Yeah, they're antis. They have the integral, right? These are what was the fancy name for them again? Indefinite or definite?
So I can't
Yeah,
remember.
do I?
That's like oh, come on, Walter. What was it? Okay.
Because your definite integrals, they have your bounds, and so you can find the answer. But your indefinite integrals, it doesn't have any bounds.
Ones then.
Yeah. So that's when you have your x's and your y's and stuff like that.
Okay, so the antiderivatives are also known as indefinite integrals.
Mm-hmm.
Yep. Okay. Cool stuff, right? You know that those bounds things, man, they're way cool. That you could, I mean, like find the area under a curve in that way.
Yeah.
Like weird.
Like, your bounds and stuff, and you get your answer. I think that's really awesome.
Weird, but pretty awesome, yeah. Okay, so let me see here. Yeah, these rules are important, guys, because I'm like so sure that you're gonna see that on the test, like so sure. You're gonna have like a e to the u problem, ln u, and you gotta know that it's 1 over u times u prime. You know, the tricky one here for me, I think, is that a to the u one, because you see e to the u and a to the u. What's the difference between them? You know.
So a is just a variable, but e, when you plug in e, it's an actual.
I know that. I know that e is the e function.
Yeah.
A is the variable.
Number, so it's going to be a little different.
Right. But what I mean is, I might get confused thinking that e to the u is e to the u ln u.
Even if you do like the a to the u with the e, and you plug e in for the u, I mean for the a, when you take the ln of e.
But the ln of e is that's what I was going to say.
Cancels out.
I'm gonna feel kind of funny taking the ln of e. Hopefully. No, but I could do something stupid like e to the u times u prime times ln of a. You know what I mean? Like ln of u. I mean, sorry, ln of u.
Oh, okay. I see what you mean.
Not ln of e. ln of u. So yeah, watch out for that one. I don't know, but honestly, those are straightforward. Too. U is just you know, you guys know. Yeah, just follow the rules, get the answers. How do you guys feel about the chain rule and stuff?
The what?
The chain rule. Chain rule.
I feel like I was good at it. It's been a little while.
Okay. Can I throw a problem out there? This was from from an activity here. Square root of x to the third plus 8.
Okay.
And then right next to it, you have parentheses, 4x plus 1 squared. So 4x plus 1 all in parentheses and then squared.
Mm-hmm.
Yeah. I don't think we should go all into it because it's not part of the meeting here or whatever, but
I mean, part of the meeting is to answer questions that people have, so
I guess so. That's true.
It is something that.
How would you guys go about solving this one?
I think we could do that.
Did you guys see the problem?
It looks like that, right?
Let me see. Where is my Google? Okay. Yeah. Yeah, that's it. And y is equal to all of that, pretty much.
Okay.
So they're asking to find the derivative of that whole. If there's one thing I've learned is that you have to learn to recognize groups of functions. Like there's always different ways that you can get a derivative. But sometimes there's an easier way if you a rule or a group. I mean, right here, I see that I can use the chain rule twice instead of having to multiply those guys together and separate them all out. And yeah, anyway.
What is that? I don't know. Just blanked on how to do derivatives. Not functioning yet. Okay. Did I do that right? Derivative, you bring that down. Would that like be your first step for this thingy? I don't know.
Let me look, guys.
Just don't.
Okay,
so it's basically the product.
You change those to there, and then
derivative of the first times the second plus the derivative of the second plus this one, right?
So wait, say that one more time.
And then the derivative of the first plus what the second one is. I mean, times, and then you add the derivative of the second plus the first. Am I thinking right, or?
Yeah, what you do is you take the derivative of the first, multiply it by the second one, and then you add it by the opposite of what I just said.
Yeah. That's all we're doing for that equation, isn't it?
Yeah. Mm-hmm. Yeah.
I'm pretty sure that.
But the tricky thing is taking the derivative of the chain rule.
Taking the derivative of what?
of the of the equation, like the chain rule, and remember to include everything.
Yeah.
That's the tricky part because you're including a lot.
Yeah.
So I don't know, you know. But yeah, I just know one of these problems is gonna be on there. That is probably like this.
So I should be able to simplify that. I guess not. I don't know. I think that's what I got for my answer for that. I don't know if you can follow it, but
let me see what I got. Okay.
That might be horribly wrong.
That looks right, man. I'm just that's what I remember me getting. That looks right. But
yeah,
I'm just gonna say it looks right. I just too sure. Where is it? Oh, I just had it. I don't know. I don't know where it went. Colin, did you get the same thing?
Yeah, I'm still just working it out right now.
I remember that 8x plus 64 though, Austin, and I remember the moving it back down. I think you got it. So yeah, it's kind of weird because you're doing the chain rule and you're doing the product rule too, with the products of the chain one. I just felt like it was a tricky one, you know.
Okay.
And did you guys have a question on one? You guys wanted to work together, like I think there's like 3, 4 main topics, new topics that we learned. I think there's the anti-derivative ones, you know, that going since last week. This week we got the new area under the curve stuff. Yeah, I'm not gonna stick around forever for this group meeting. Sorry, you guys. But if you guys want to meet tomorrow, we definitely can.
I'm always down if you still want to. It's
yeah,
doing more work here.
Just to get some more studying before the test, you know. Oh, found it. Finally. Okay, what did you get, man?
I had 4x plus 1 over the square root of 1/2 plus 8x plus 64.
Uh-huh. Oh, I see. found it. Now, here's a question for you. Would it matter to move it back to square root form, or can you leave it in the parentheses to the 1/2?
You can leave it in the parentheses to the 1/2 if you wanted.
Yeah,
I find it easier to read than the square root.
Because that's what I did. I just left it in the parentheses to the 1.
I don't think it matters. It's just easier for me to understand if I leave the square root there. Okay. I'm just looking at activity B for the day. I don't really understand what's going on with it. Like, when you're finding the derivative of something using the logarithmic differentiation. I don't understand how things happen there. Does anybody else?
So, instead of the 64, man,
yeah,
I actually got 32x plus 8.
32x plus 8?
Yeah, here, look, let's see what I did. Not right there.
Ooh,
you see that?
Okay, so it's 2 times oh, what? Oh, hold on. Do I have my equation written down wrong? I think part of my issue is that I have this. Yeah, I forgot to do something with this equation. I really messed up the equation. I didn't carry the cube down. That makes a big difference.
Gotcha. Like I said, it was tricky, huh?
Yeah, I just left out the cube. I think that was part of my issue.
But yeah, I don't know. I'd have to look at the answer sheet, see which one's right.
Okay.
I can't remember. I don't even remember what activity this was from.
Okay.
Might have been the last one.
Oh, I might have done something wrong there. Okay.
But you can see the whole thing there?
Yeah, I think I understand what's going on there.
Did you have any questions, Colin?
Nope, I don't think so.
Good.
Okay.
Did you get Austin's answer or mine?
I got Austin's answer first, but I did the same mistake.
Oh, nice. Oh, yes. Well, don't be so quick to call it a mistake, man. I don't know if I'm right. Yeah.
Yeah. I think I forgot to do something. Oh, when you do the thing inside to power, it does something weird, doesn't it? I totally forgot stuff there. You do the derivative of the outside times the wait.
You do so you multiply it by the derivative of the inside function. So you basically do the chain rule on the function, and then you multiply it by the derivative of the inside function. Like, for example, this guy right here. That guy.
Okay.
So you take the derivative. I mean, you do this.
The derivative of the outside times the inside. That's what I did wrong. I forgot about that rule.
You got to multiply by the derivative of the inside function.
Yeah, I forgot about that part.
Yeah.
I was forgetting how to get that 3x.
So see, I almost forgot the 3x there.
Yeah.
That's what I'm saying. So
yeah,
it's a lot you're multiplying together.
Yeah, I forgot about that little rule right there. I just realized that I forgot it. You're like, oh, there's that one too.
Okay. Right.
Oh my. That just made that problem massive, didn't it? Because when you multiply it, so the derivative of the first, which is that outside thing times the derivative of the inside, derivative of outside times derivative of the inside, then I multiply that times 4x plus 1 squared, don't I?
Yeah. Yep.
Oh, gosh. Yeah, okay. I see where I went wrong. I went horribly wrong. I tried to skip like half the steps.
Man, it's all right, man. You know, you're just waking up.
You know? Yeah. And, oh, man, this is going to be a test.
Thank goodness for extra credit points. I don't know. No, let's try to get them right, you know. Let me see. I'm trying to think of other problems that I'm struggling with, but I mean, I already mentioned one that I thought was tricky. You guys got any in mind? 20 minutes left.
I'm not too sure with what I have on the top of my mind right now, but I didn't come super prepared for this one, to be honest.
Oh, it's okay. I mean, a lot's been thrown out at us. But at least for that derivative and logs and exponents, I feel comfortable with them as long as I have those rules in front of me.
Yeah.
If I don't, I'm like, wow. What was it again? LMU.
Oh,
LMU is just 1 over u times u prime.
Yeah.
I only know that because I'm looking at it straight ahead. I just want to sound smart, you guys. No. Okay. What do you guys do to memorize these? Do you like write them down a bunch of times? You just read them?
It's usually just working through the problems for me, but I mean, I haven't done much work this week because I started a new job, so I've been all lost with getting my homework done, to be honest.
Nice. Oh man.
So like, I haven't touched any calculus really this week. This is the first time I really touched it.
Well, hey man, get on that homework, dude.
I know.
It's like 20% of your grade.
I know.
And homework. I mean, it's the 3rd week already, but how many weeks of school are there? 12?
Yeah, there's 12 or so.
So, yeah, that's already like, what is that? 5% of your grade, man.
Well, if it's only 20% of my grade, like total, and it's 1 week, that's like a 1.5% down.
You still get a 95.
Yeah.
Yeah. No. Shoot. Yeah, no. Do as much as you can. Huh?
Yeah, I'm working on it. It's just this new job is.
Did you do the one for today?
I was working on that right before we got on.
Oh,
just a little bit, but
I would recommend doing the prep assignment first.
The what?
The prep assignment first.
Yeah.
And the homework.
Yep. That's what I was sort of working on going through the prep stuff just for learning it.
Okay. So right. find the derivative. Yeah, no, like I said, I feel pretty good with that. These activities really do help prep for the test, though, because they show you the right way to work through them. You know what I mean?
Yeah.
Just okay, so for that first one, all right, that's a 3. That's an A to the U one. You know what I mean?
Yeah.
Right? So they basically just did A, which is 3, to the U, which U is the function, A to the U, times the derivative of U, which is just 2x minus 4.
Mm-hmm.
And then they multiplied it by ln of A, which is 3. And that's literally it.
Yeah.
They just followed it step by step.
So that's just your answer because you can't really go any further, right?
You can't, or you shouldn't go any further.
Yeah.
I mean, because ln of 3 is a number. You can times it by that number, you know, but you wouldn't want to do that.
Everybody.
You would confuse everybody, right? They're like, how'd you get that number?
Exactly.
It's the ln of 3, dummy, don't you know?
Yeah, it's simply, 2.543 or something like that.
Okay. For that log one, that's the last one. Log of A, U. And like I said, they basically followed it. 1 over U times U prime times 1 over ln of A, which is 5. Yeah, so log AU. Yeah, we gotta know those rules, guys, because I just know it. Yeah. And once you know the rule, then it becomes simple. But is there a problem here where the rule doesn't exactly match up? Like, for example, that third one right there. E to the something weird. What would you do in that case?
Oh, I mean, it's still e to the u times the derivative of u, which you're doing the derivative of that x plus 1, which is
okay. So let's see, e to the u times the derivative of u. Let me see what I get. Yeah, e to the u times the derivative of that is just I see, x plus 1. It's the quotient rule, huh?
Yeah.
The quotient rule again. That thing was, oh man, I almost got this one wrong on the last test, almost, because I couldn't remember if it was the derivative of the bottom function squared or just the bottom function squared. Thank goodness.
Yeah, it's just the bottom.
It's just the bottom function squared. Yeah. So it's just the bottom function times its derivative, the derivative of the top minus the top times the derivative of the bottom.
All over the bottom squared.
All over the bottom squared. Yep. And then you simplify that.
Yep.
And you get e to the u times that. Okay. Oh, I like this one. ln of ln x. Isn't that confusing?
Yeah.
That is confusing.
I mean, it's just
ln of u.
ln of u.
That's the formula there. ln of u is equal to u 1 over u times u prime. So u is ln of x. 1 of ln of x. But then what is the derivative of ln of x?
It's 1 over x times the derivative of x, which is 1.
Well, the derivative of ln of x is 1 over x.
Yeah.
And so it would just be 1 over ln of x times 1 over x.
Yeah. Okay.
Okay, I'm still trying to wrap my head around that one, you guys. 1. Okay, ln. Okay. I got the first part times u prime. So the derivative of ln of x is just 1 over x.
Exactly.
Why isn't it 1 over x times the derivative of that, you know?
Yeah.
Well, what's the derivative of 1 over x?
Why would you do the derivative of 1 over x?
That is x to the negative 1. And then you use the power rule. Negative 1 to the 0 is just 1. That's why. That's why it cancels it out. You see that? So that's why it's just 1 over x. Because the derivative of 1 over x is something to the 0 power, which is just 1.
Okay.
Did you guys get that? What am I talking about there? Or am I crazy talking?
I think I understand what you're saying. Okay, I understand that one.
Yeah. Yeah, it was just tricky to me because of that. But you're right. Ln of x is just equal to 1 over x. Yeah.
Yeah.
And I do remember that one. But that's why, because the derivative of 1 over x is just x to the 0. Negative 1x to the 0. Which is 1. Right? Not negative 1. It's just 1.
Yeah.
Right?
I think so. Cool. What? There's so much writing to do for all of these things.
Okay. Let's see. And then the next one there, x squared times 4 to the x. Right?
Yeah.
That's okay, that's a to the u times another a to the u.
That's what I'm trying to figure out right now.
Yeah, right.
What?
The a to the u times a to the u.
For the fifth one?
For the y equals x squared times 4 to the x.
You're doing your product rule there.
Yeah, right. Product rule. So you do the a to the u.
Yeah, a to the u times x squared.
Times the derivative of that. The derivative of u, I mean, which is, 2. What's the derivative of 2? It's just 0 there. Yeah, you wouldn't multiply them out first, right?
No. Cause I'm looking at the key right now.
Yeah.
And so I understand it until the very last part of that answer.
So she did the first times the derivative of the second plus the second plus the derivative of the first.
at the end she has times ln of 4. I don't understand where she got ln of 4 from.
That is because it's the AU rule, the AU times U prime times ln of A.
Okay. Yeah. Those rules are kicking me in the butt.
Yeah.
Yeah, that
you took the EU rule
dude,
instead
Austin,
of the AU
if you can break down that one for us to dumb terms, I'd appreciate that one, man. Because yeah, I'm confused as well, Colin.
I mean, it's just following those 4 rules up there. I mean, it's just being careful of the A's and E's. Like, that's what you're doing there. You're just getting your A rule mixed up with your E rule, I think.
Okay.
I mean, if it's easier for you, make that E rule the ln of E up there. Like, ln of E, that just cancels and you can just cross that out later. Like, if you need to, just write it out that way every time, just so that you get it right.
No, you know what the problem is? I'm trying to do it in my head.
I mean, yeah.
I haven't written down.
Yeah,
that's the problem right there.
Write down those rules so you can just have them to look back at and be like, oh, that's the rule, okay, rather than like trying to remember.
That's the problem. That's the first problem, I should say.
Like, if you can write down those rules every time, like if you go in the beginning of the test, like just write down your 4 rules or whatever.
Yeah.
Go back to those every time.
Yeah.
It makes life a little bit easier.
That'd be easy because the mind gets tired.
Yeah.
As the test progresses.
Yeah, I know that's the way a lot of people take tests. They'll memorize a whole bunch of formulas and then just go brain dump it real quick on the test and then just forget it all, and then they can use the back of the paper for all those formulas.
Yeah.
But
to the tip, man.
And that's one way to do it, but we have to continue probably remembering these things throughout the whole semester, which is going to be a pain in the butt.
Oh,
yeah.
Sure. Because everything's cumulative.
Right.
That's another issue with calculus, is it's just it keeps on adding and adding and adding. It's like, it's not always going to get easier, but
that's why you really don't want to fall behind, because then you got to double the work, triple the work.
Yeah.
Okay.
Yeah.
So basically, the derivative of x squared is just 0.
What? The derivative of x squared should be 2x.
Yeah, it's 2x.
What? Oh my goodness. Oh my goodness. Oh goodness. That's what I'm. Okay, get this, guys. Get this. I was trying to treat the x like an a. So I was doing a to the u for x squared.
All your a's and x's correct.
Hey, try that. Try to do that. Hey, try to do that.
Wait, treat the x like an a.
Make it an a, yeah. A squared. A squared.
A squared. I mean, if it's A squared, it still turns out to be.
Yeah. No, I know. 2A to the But I'm saying use the A to the U rule.
A to the U rule.
Yeah. A to the X to the U is equal to what you learned. X to the U is now equal to A to the X to the U times X. Okay? And you get 0. So.
Oh gosh.
Okay. Okay. Now I understand the problem. Wow. Okay. I'm done. I'm so done.
Yeah.
And it's 11, so I gotta go.
All right. Call it.
Yeah, no, you guys want to meet tomorrow and talk about those because I want to talk about the indefinite ones.
Okay.
The ones like area under a curve, because I know we were gonna have just at least one problem, because that's one of the long ones, you know.
Mm-hmm.
But yeah, but that's cool. I mean, do you guys want to do it tomorrow at 10?
I can.
I have a class tomorrow at that time.
You got a class. Oh,
yeah.
Okay. Well, sounds good, man.
But yeah, if you guys have any questions, I mean,
if anything, Austin, I can just drop by your house, man.
Yeah, that works too.
That works too. All right. Thanks, man.
Yeah,
and
thanks,
I'll see you guys later. I will email you guys this broadcasting.
Okay.
Or yeah. Okay, give me a second here.